This is question 4 from the mock test. And this is a rocket. So let's draw a safe rocket here. There we go. There we have it.
It looks like mine.
That is a pretty good rocket, isn't it? All right. Okay. And it takes off. It's a 24 kilogram rocket. And it reaches a height of 52 meters, which is going to be really hard to draw here.
I enjoy your illustration.
Goes up 52 meters. It's a very tall rocket to begin with, you know. Okay. And it goes up 52 meters in 1.89 seconds. Right? And so what do you suppose from rest to 52 meters, 1.89 seconds, what am I trying to get you to do?
Find velocity.
Not velocity. You're not going to find velocity. What do we care about? Acceleration is what we care about, right? Okay. So, I mean, we could do that by finding velocity, but that's really all we care about. So the first question is, what's the acceleration of it? We got x, vi, vf, a and t. X is 52. Initial velocity presumably is 0. Final is, we don't really give a hoot, but we could use it, right? And then the time is 1.89 seconds. And then what do we want to do? Which,
Df equals vi plus 8.
does that work? I don't think that works. I think we need something with x. We need one that's no vf.
Oh, I realized what I did wrong. I didn't.
Is that vit plus 1 half at squared? Is that the one?
That's what I said.
Yeah. So we want to use x is vit plus 1 half at squared. And I think we can find the acceleration from this, can we? Especially because this guy's 0, right? So I'm going to go 52 is 0 plus 1 half a times 1.89 squared. Right? That makes it much more easy to solve. So we can find the acceleration. It's going to be this divided times 2 divided by 1.89 squared times 2 divided by 1.89 squared. So that's 29.11. We'll say 115. That's way enough sig figs, right? Da-da-da. Should have drawn my rocket smaller. It's bothering me, but you know. By the way I drew this rocket, I put 4 fins on it because there'd be like fins here, you know. But rockets always have 3 fins because they don't fly straight with 4. I'm joking. I don't think that's true with arrows, though, isn't it? Have you ever tried to make your own arrow and put 4 feathers on it? It's way easier to put 4 feathers. Like fletching. You guys never made your own arrows? We made our own arrows. Back in my day, they were steam powered. We didn't have the internet. No, it's pretty funny. They'll fly. You can shoot an arrow that way, and it'll, honest to God, just fly in a big circle, just like. You can shoot around corners. Okay, what force would be necessary? Whoops, where are we? We're on 4. What must be the upward force exerted by the engines? Okay. We want to find the force on that one. Why can't I just say that it's 24 times this acceleration?
Because, wait, what was the question?
Why find the force exerted by the engines? Why can't I just say F equals ma and multiply this guy by this guy?
Because you have the
The opposite, the weight. Yes?
Yeah.
There's a downward force equal to the. Turns out when the slideshow turns on, nobody pays attention at all. Right. And so we've got to figure out the weight of the rocket. The weight of the rocket is 24 times 9.8 is a number. 24 times 235.2. Right? And now we can set up an equation here with our little rocket. We've got an unknown force. We know that force is up, but we're going to pretend we don't. We've got a downward force, which is less. This force is 235.2. This force is F, right? And now we can just set up our equation. Let's go F minus 235.2 equals 24 times, and then this is a positive acceleration. Like that. And again, it's going to be this times this plus that, right? So add. That's a 24. This guy's a 29. It's the answer to part 24s and 29s, yes. Times 29.1145526. He just kept going. 933.9. Bless you. Blah, blah, blah. Are we okay on B? And then, you know, suppose the engines couldn't put out that much thrust. They could only put out 430 newtons. What would they do? So suppose that the rocket now has 430 newtons up. The force down is still 235.2. Well, this guy's negative, this guy's positive, and we would just set up a 430 minus 235.2 equals 24A. So that's how you solve. That's the same as like the mass on the string. That's the second question too, right? Because you got to calculate the. So 430 minus 235.2 divided by 24. And I get that the, and this seems highly unlikely, but the acceleration is 8.116 repeating. 6 meters per second squared. 6. You did it a different way. Did you get the right answer?
Yeah, I got 8.11833.
Did you get, could you do it again on a test? Then you're probably, then it's not so good, right? If you do it a different way, you know, this is, I know there's a way to do this. I know for this one, when you got the acceleration, you can cheat and just say that you can just like add 9.8 to this and then multiply that by 24 and you get the same answer, right? Because ultimately all these problems up and down work out to this notion that the force is equal to m times a plus g, right? And so you could just add the 29 plus the 9.8. Harder to do it when you know the force, but